Good morning, everybody. We're going to look at our last section of this unit, and which is going to be quadratic models. So we're going to be looking at how we can apply quadratic models to real life phenomenon, talk a little bit about where you will see those and kind of what we can use those to solve for. So typically when you're dealing with quadratics, when you're looking at these models, you'll anything that flies through the air under the influence of gravity, projectiles will work. You can also any problem involving area of a rectangle or area of a square, you can use a quadratic model for. You can also use it to try and tell the maximum or the minimum if it is a quadratic model. There's a couple of different uses. So we're going to look at a couple of problems that illustrate each of these and kind of some things to look for and whatnot. So the first problem we're going to look at is example 21. This is on page 154 in your all's orange book. And so what we've got here is we've got when a baseball is hit, its height above the ground after t seconds is given by the function height over time, h of t, is negative 5t squared plus 30 times t plus 1 meters. And t has to be greater than 0 or greater than or equal to 0 because you can't have negative time. So the first thing that we're going to do is we're just going to evaluate the ball's height after 2 seconds. So here we've already got this quadratic model written. And so the way it's written, if we want to find the height at a given time, if we want to find h of 2, we're just going to substitute in 2 for everything and then evaluate. So negative 5 times 2 squared plus 30 times 2 plus 1. Let's see here, that's going to be 60 plus 1. That'll be negative 20. And we're going to get, what, 41. So the height after 2 seconds is going to be 41. I need to include the units, feet there. So then the next thing that we're going to answer, and so is about the maximum height. So when you are working with a quadratic model, a good thing to get in the habit of is to kind of sketch an idea of what this thing would look like. So for this thing, I know that it's going to have an intercept of 1. By the way, that should have been meters, excuse me. This should have had an intercept of 1 meter because that is the C value there. And this is going to be some sort of parabola that opens downward because of the negative A value. So we know that we're going to have a maximum height. So when we're trying to find the highest that this thing gets, what we're trying to find is the vertex of this parabola, more specifically, the y coordinate of it. So let's see. To find the x coordinate, the axis of symmetry, we're going to do negative b over 2a. So let's see. That's going to be negative 30 over negative 2 times negative 5. That's a regular 2, excuse me. So that's going to be negative 30 divided by negative 10, or x equals 3. So that is, after 3 seconds, that's going to be the maximum height that occurs there. But what we need to find now is, so on B, we're finding how long it is. On C, we're going to find the maximum height. So after 3 seconds, this thing is going to hit its highest height. So now what we've got to do is we've got to evaluate what h of 3 is. So we're going to say negative 5 times 3 squared plus 30 times 3 plus 1. So let's see, we got 90 plus 1 times negative 45, or plus negative 45. And that's going to give us 46. So the height after 3 seconds is going to be 46 meters. And so again, we can use our model. So once we get that vertex, you could also, to make it a more accurate picture here, we could say 3 and 46. If we're asked to find more stuff in this, I cannot emphasize drawing a picture is usually the best way to make it make sense. If you don't have a picture, I would try to draw one so that way you can see, okay, is what I'm figuring out, does this make sense? So then the last question we want to ask is, how long does it take for the ball to hit the ground? So if it's going to hit the ground, that means that h of t is going to be 0. The height is going to be 0. So we're going to set the height equal to 0, and then we're going to solve for the value of t that's going to make this work. So with this, I do not believe that this is something that can factor. So what I'm going to do, so we could complete the square, we could use quadratic formula. I am just going to graph this just to get a better idea. So let's see, we've got the equation 0, we've got negative 5x squared plus 30x plus 1, and we want to see what that graph looks like. So you can see there's two intersections here. We've got that no, that's the y-intercept, excuse me. So we've got that intersection right there. So when t is we're going to call that 0.03 seconds. And then let's see, can we get the other one? It only wants to do the y-intercept for some reason. So anyways, the intercept that we're concerned about is how long it's going to take till it hits the ground. So this graph, this model represents that height of the baseball. So we're going to say it's going to be 6.03 seconds. Alternatively, if you wanted to go in and use polysmalt here, polynomial roots finder, it's a degree 2. The coefficients are -5, they're 30, they're 1. And we go and we solve for that. Okay, so that's why I was having such an issue finding. So you'll see that there's actually a second answer here, 0.0331 seconds. And that's negative, but we're not going to count that answer because that is negative time. That does not count as part of our answer because negative time would be time travel. So we are not going to include that. So then the next, we're going to look at two more together and then we'll call it a day. It'll be a pretty short day. So the next one that we're going to look at is we've got a gardener here. So a gardener has 40 meters of fencing to enclose a rectangular garden plot where one side is on an existing brick wall. So here's our brick wall. They're building here, they're building here. So suppose the two new equal sides are x meters long. So we're going to call this, we don't know how far, but it is going to be a rectangle. And these are going to be x. So when we're setting up this problem here, since it's a rectangle, this is going to be the same measurement as this. And we know that we can use 40 meters of fencing here. So to get this dimension right here, what I'm going to do is I'm going to take the amount of fencing that I have, 40, and I'm going to subtract x twice because whatever I use for this, I can no longer use for this. So I'm going to call this 40 minus 2x. And that's going to be the length of this width part right here. So now, to calculate the area here, so right here what we're going to do is we're going to show that this is actually the formula for the area. So to get the area of a rectangle, you just do the length times the width. In this case, x is our length, 40 minus 2x is our width, excuse me. So that's going to check out. And so now what we want to do, given that, we want to go and find the maximum area, because if we've got a certain amount of fencing here, we want to make sure that we are giving ourselves the most amount of space for a garden. So what we're going to do is we've got to find, so we've got this function here. I'm going to go ahead and distribute this 40x minus 2x squared, and we've got to figure out what is the maximum amount of height that we can use for that. So in other words, and I'm going to rewrite this to make it a little bit easier, negative 2x squared plus 40x. We want to figure out what is the vertex of this quadratic right here. So again, we're going to say, well, I'm going to do negative b over 2a. So in this case, that's going to be negative 40 over negative 4. And let's see. So that's going to give me an x value of 10. And so from there, so from there, we know x is going to be 10. To get the maximum amount of area now, we're going to take that 10 and we're going to substitute it back in to right here. So let's see that to get the area, we're going to say negative 2 times 10 squared plus 40 times 10. And now to get that maximal area there, let's see, that'll be negative 200 plus 400, which will give us an area of 200, what was our square, or meters squared, sorry. So that's going to be our area for this thing. And so if we want to go ahead, so we got the length, which was 10. If we want to go ahead and get the width, we can just substitute 10 into our width because that's also in terms of x. So 40 minus 2 times 10 is going to give us our width. So 20 is going to be our width. And you can try some different dimensions here if you want, just to see if that's the maximal, to see if you can figure out if there's a bigger rectangle given these dimensions, given these constraints. And the cool thing is you're actually not going to be able to find one. We have a finite amount of fencing here. There is only one optimal solution, which I think is pretty cool. So we're going to look at one last example here, and we're going to call it a day. So we're actually going to do number 15 or number 9 on page 157 there. I thought that was a 15, excuse me. So what we've got here is we've got a cricketer hitting a ball in the air, and this is kind of the path that the ball is going through. So after 10 seconds, it is 9 feet in the air, or 9 meters in the air rather. And actually, this is all horizontal distance. I need to read this graph. So this is horizontal distance of the ball. This is vertical distance of the ball. And you can see as it's traveling the different distances. So they were able to record this one way or another. So the first thing we want to do is use technology to find the quadratic model that's going to connect y and x. And so if you look at this graph, we're given some information here. And we're given this 30 and this 19. And so we can do what we did last class. If we substitute into y equals ax squared plus bx plus c, let me move that up, and we can actually write an equation that's going to model this. So we'll say 9 equals, let's see, a times 10 squared plus b times 10 plus c. We'll say 15.25 equals a times 20 squared plus b times 20 plus c. And then we'll say 19 equals a times 30 squared, let me put that in parentheses, plus b times 30 plus c. And if we rewrite these equations the way that you'll see them on the calculator format, we've got 100a plus 10b plus c equals 9. We've got 400a plus 20b plus c equals 15.25. And then we've got 900a plus 30b plus c equals 19. So we've got a 3 by 3 system of equations here, and we want to solve that. So to do that, we're going to pull up this TI graphing calc. If we go to apps right here and go to polynomial simultaneous solver, we've got a system of simultaneous equations here that we now have to solve. So let's see, 100, 10, and 1 is equal to not 89, just regular 9. We got 400, we've got, oh, not plus, we've got 20, we've got 1, 15.25, we got 900, we've got 30, we've got 1, we've got 19, and we want to solve that. So we're going to get the equation y equals 0 or negative 0.0125 x squared plus 1x plus 0.25. This is the equation that we've got that's going to represent this the flight of this cricket ball with the horizontal distance and the vertical distance. And so we want to use this model to now calculate a few things. Because the whole point of creating a model is that now we can use it to tell us other things that we don't already know. So, for example, we can now find the maximal height of the ball. So I'm going to write this model right here just so I don't have to keep referencing this page. I did not leave myself a lot of room because I wanted to squeeze this onto the last little page here, which is okay. So, if we want to find the maximal height of this right here, again, we do need the vertex. So we're going to say, well, negative b over 2a. So that's going to be what? Negative 1 divided by 2 times negative 0.0125. I'm not going to pretend like I know off the top of my head what that is. I want to say maybe it's 40. I don't know, looking at that graph, it looks like it could be 40. We'll see. Negative 1 divided by 2 times negative 0.0125. It do be 40. So we've got 40 meters for the horizontal height, and then we need to substitute that in. So I'm just going to substitute that in, 0.0125 times 40 squared plus 1 times 40 plus 0.25. So that's going to give me a horizontal height. So the maximal height that this is going to reach is 20.25 meters. And so the actual coordinate would be 40, 20.25. But what we're interested in for this problem is what is the maximal height? And so to finish this, the last thing that we want to try and find is at the end of this cricket fence. So I'm not exactly sure with how cricket works, but I imagine this is the cricket equivalent of a home run. We hit a dinger, this thing is soaring, it's soaring. We're like, oh, there's a fence that's a meter long there. So maybe this is like a cricket home run. So we want to know, okay, this thing is 75 meters away. Is this ball going to get over this fence? Is this ball, so like, is the height at 75 meters going to be greater than 1 is another way to think about this. So really all that we're asking, we want to try and figure out what the height is, what y is, when x is 75, the horizontal distance. So we're going to say, well, all we need to do is substitute that in. I wrote that wrong, 0.25, Mr. Price. I've made a ton of little mistakes today. I don't know what's gotten into me. And so I'm just going to substitute 75 in. So you can see right there, when we substitute in 75 into this equation, that we do get the height. So at x equals 75, y is 4.938. I should have called it 4.94. Goodness sakes, Mr. Price, 4.94. And so it is going to clear that fence. And so what we need to be mindful of with quadratic models, you need to always, if you do not have a picture drawn, you need to draw one yourself to help you understand it better. When we take our exam next week on quadratic models, you need to understand that most of the questions that I'm going to ask are going to be related to some sort of quadratic model, because this mathematics that we've been learning can be applied. So as always, if you all have any questions, please let me know and we can figure it out together. Otherwise, I will see you all on Thursday. Bye.